Okay, so I'll get this started as soon as I can. Click on this. No. Click on this. Click on this. Click on this. All right, here we go. So this is the one that I gave to you in class and I asked you to finish. So I'm going to do a lot of them. I don't know if I will do all of them. Well, I'll try to do as much as I can. So look at the first one. And one thing I would like to see you do is move them around. I'm not going to draw circles over. Well, I should. I'm going to draw a circle here, because I know these are like terms. So it's negative 4c, and if I move the other one around, it's minus c, and then minus 3d plus 9, whatever is that? No, minus 9d. And over here, you notice that there's a plus sign and a minus sign, so I want you to combine that and make it a negative, because a positive and negative is a negative. So rewritten this expression, I just moved my terms around. I get this. Now, your two like terms start over here and end right here. And that says negative 4c minus c. And if you change that to an addition problem, oh, my pen. It's negative 4c plus negative c. So here you get negative 5c, right? Because they're both negatives, right? And then negative 3d minus 9d. And again, if you want to, you should change it. Negative 3d plus, oh my god, my pen's not working. Plus, what is going on with my pen? Negative 9d. Again, they're both negatives, and you get negative 12d. Okay, something's wrong with my pen. Let me try that one. Okay, let's try that one. Again, I'm gonna not circle. Okay. What in heavens? Maybe it's not clean. Negative 7m minus 2m minus 5n minus n plus 3p. So again, I'm just rewriting my expression so my like terms are next to each other. And again, this is what I'll focus on. And then these two starts at that minus sign. It goes all the way here. And the 3p, you notice. So I know my expression is going to be something plus 3p. These two is negative 9m. And these two is going to be negative 6m. N. Okay. This one, again, it's negative 4. What? I'm going to pause this. I got to pause this. I'm going to start or clean my board. Maybe that'll make a difference. Pause. Okay, so after cleaning, let's see if this worked. So where was I? I was somewhere over here. It's negative 4x squared. The same problem. I'm going to pause this again. All right, so 4x squared minus 9x, I think it's the pen, minus 9x squared. Oh, come on, don't do this. I might have to buy a whole new pen. Plus 5x minus x. And then minus 7 plus 19. Again, I just rewrote the expression so the like terms are next to each other. So you gotta just really be careful as to where the like terms start and where it ends. So it starts to me in the blue color. It starts here and ends right before that sign there. So negative 4x squared minus 9x squared. If you like, please change it to negative 4x squared, right? Change the subtraction to addition, and that becomes negative 9x squared. And they're both negative, so that becomes negative 13x squared. Plus 5x and minus x, that's simple enough, right? You have 5x, and you take away 1, you end up with positive 4x. And then this negative 7 plus all the way to the 19 is just going to give you plus 12. Okay. And I'm going to skip around. I'm not going to do all of them, but these two I will do because that's what I gave you a little problem. The 3a is not going to be multiplied by the terms inside because it's not outside the parentheses. This says negative 3a minus parentheses 5a minus 7. The only number that would be applied here, the distributive property, would be this invisible one that's not here. So what's the purpose of the distributive property? The purpose of the distributive property is to remove the parentheses. So think about this 5a as being right now sheltered, protected. 5a minus 7, it's inside this parenthesis. And even though the 3a that's outside, the negative 3a, is a like term, I can't combine it because it's protected. So we got to remove this shield. So remove that by doing the distributive property. We got negative 3a, and that's doing absolutely nothing. And then remember I said in class, I want you to think of this 1 as a negative 1. Okay, so negative 1 times a positive 5 is going to be negative 5a. Negative 1 times a negative 7 is going to give you positive 7. I can now combine these two. Oops, I went too far. Negative 3a minus 5a. I mean, again, I don't want to sound, and I'm pretty sure I sound repetitive. Change the subtraction to addition. And the 5a becomes negative 5a. And I will put that in parentheses to differentiate that. And now I have two negatives being added together, so I just get further left of the number line, negative 8a, and then plus 7. This is the same as this same problem. The y, it has nothing to do with anything. The y is ready to be added to the 9w, I'm sorry, but we got to remove the parentheses. So again, put a little 1 here. And if you multiply this one times this and this one times that, you're going to get the exact same thing because it's a positive, right? Positive and negative is a negative, and then a positive 1, negative 5 is still negative 5. So it comes out exactly the same. So literally, if you noticed, when it's a positive 1 outside here, you're literally just removing the parentheses. So imagine you're just removing the parentheses because the negative 9y comes out as negative 9y. Negative 5 comes out as negative 5. And then you put plus y. Let's add the like terms. And again, let me put these two together. Plus y. So these are the two terms that are like. And again, measure. These were rocks, and I could lift the rocks, and then the plus minus 5 would go all the way in the end. Negative 9y plus 8y, simple enough. 8y minus 5. Okay. Oh no, I'm gonna have to buy a new bamboo tablet. Well, this lasted me quite a few years actually. Again, it's a minus, so we have to remove the parentheses. We have to remove the parentheses before you combine any like terms. So I'm gonna put a, and I can make this. I don't know why I always do this. I can make the numbers bigger. Hey, technology. There you go. I want you to put, if you need, and it helps, 1 here and a 1 here. So it's a negative 1 times a negative 2b. So this negative is going to change those two. So when the terms inside the parentheses comes out, whatever is negative becomes positive, and whatever is positive becomes negative. So it's come out like this. So it becomes 2b3 minus 9a. Negative and a negative is a positive, and negative and a positive is a negative. And that's how it comes out. Now notice this here, it's a plus 1, right? So when it's a positive 1, everybody who is in the parentheses, they come out exactly how they are inside the parentheses. So positive times a negative, notice it comes out at negative 3b cubed. And positive times a positive, and 1 times a, positive 1 times a is just simply same thing, plus a. Can I combine something? Yeah, I can combine this guy. So I'm going to rewrite my expression. I'm going to move this guy around. Notice that I circle the minus 3b cubed. And then I'm going to move the minus 9a plus a. Okay. Underline if you want to. Okay, you don't have to do this forever and ever, but until you get used to and know who the like terms are and where it starts and where it ends, so you don't get confused. So 2b minus 3b cubed, so you can rewrite it as 2b, right, plus negative 3b cubed plus. Does that help you see the problem a little better? So there are more negatives. How many more? 1 more, so it's just 1, negative 1b cubed, which I am just going to erase. I'm not going to write 1 because it's not necessary. So that becomes negative b cubed. And minus a plus a, obviously there's more negative, and you get negative 8a. Same. So I guess the next few problems become repetitive, but it's a exercise on you getting used to what happens when there is no numbers outside the parentheses, and you imagine there's a 1. What happens to the terms inside when it's a negative, a minus side outside the parentheses, and what happens when there's a positive, a plus. So in this case, there's a minus, right? So I put the 1 in there. So I'm going to erase it. So if you imagine the 1 there, it's going to be negative 1 times 4c and negative 1 times negative 2m. So everybody who's inside comes out negative. Sorry, comes out the opposite. Negative 4c. And minus 2m comes out as positive 2m or plus 2m. So imagine negative times a positive gives me this negative. And this negative times that negative gives me that positive. Okay. And likewise here, this negative, this minus, and this minus is going to give me 5k. Right? So imagine there was a minus 1 over here. Minus 1 times negative 5 is positive 5. And then minus this negative 1 times this negative 8 is going to give me 8m positive. So as you can tell, they were both negative inside the parentheses. When it came out as 5k plus 8m. Do I have like terms? Yes. The only two like terms I have is this guy and this guy. So negative 4c plus 5k, and I'm doing this alphabetically. And then finally 2m plus 8m is plus 10m. Okay. Ooh. All right, so yeah, you got the brackets. So here, the brackets, right, in the parentheses. So let me just move things down a little bit. All right, so here we go. 7m does nothing. Plus minus 2m, and the first set of parentheses I'm going to eliminate is the inside. So this is a minus, right? So that's going to change the sign of these two guys inside. If you pretend there's a 1, negative 1 times negative 5 is going to be positive 5m. So first thing I'm doing the distributive property, so I can remove the parenthesis sign. And again, negative times a negative, it's going to be plus 2. So my parentheses are gone, and I'm left with the brackets here, right? Remember, 7m is not being distributed. You're not multiplying 7m times negative 2m plus 5m plus 2 because there's a plus sign, right? So again, treat these as parentheses and imagine there was a 1 over here. So that would be being multiplied, right? Distributive property. So again, because it's a positive one, it's going to come out exactly the same. So 7m, and then positive times a negative, it's negative 2m. So you notice that 2m came out exactly the same. Positive and positive is positive 1, 5m. It's going to be 5m. And then 1 times 2 at the end is going to be plus 2. Can I combine anything? I can combine all these three guys first. So please do it from left to right. 7m minus 2m is 5m, and 5m plus 5m is 10m. And then we get 2. Okay. Likewise, now you have to get, so there's 3 different brackets here, right? So you got to get rid of the parentheses, there's brackets, and I forgot the name of the other one here. So you got to do it by steps. I'm just going to write 3y squared minus, this bracket right here does not eliminate first. So the first thing we're going to remove, and again, that stays, this one also stays, is the parentheses. So these two guys are going to disappear first, right? But so we remove the parentheses, but that minus sign here, and again, if you imagine there's a 1 there, minus 1, negative 1, and negative 1 times negative 4 is positive 4, so everybody is going to come out the opposite. Negative 1 and negative 3 is positive 3. Well, you notice now that everything stayed, and the only thing that disappeared between this expression and the previous one is that there are no more parentheses. Next thing I'm going to eliminate is these guys here, and I'll highlight that with blue. These two things are going to disappear, and you treat it the same way. Minus 5y, and again, you want to imagine there's a 1 here if you can, and you're going to do the distributive property, right? And because it's a positive one, and everybody's going to come out. So when you move the blue brackets here, everybody comes out exactly the same. So 1 times 2 is just 2y squared. 1 times 4 is plus 4y because it's both positive, and then 1 times 3 at the end is plus 3. And notice now that these two, the blue brackets, are removed. And for last, and I'll do it pink, I guess, I'll remove these guys right here. Okay. There is no number outside. There could have been a number so that you could have done this distributive property, but it just doesn't. The problem doesn't call for it. So minus, and let's again this minus, put a 1 in here, and that's the one that's being applied. So that times that, that times that, that times that, and that times 3. Because it's a minus, a negative, everybody comes out of these two brackets the opposite. So negative 1 times negative 5 is positive 5y. Negative plus 2 times 2y squared is going to be negative 2y squared. Negative 1 times 4y is going to be negative 4y. And negative 1 times positive 3 is negative 3. All my parentheses are gone step by step. Can I combine like terms? Yes, I can combine this guy over here with this. I'll put a square. I'll put a square over here. So at the end of my expression, you know it's going to be minus 3. Something, something, minus 3. So negative 3y and negative 2y, it's going to be negative 5y squared. And 5y minus 4y is just simply positive y plus 1y or just y. That's the answer to my problem. Okay. Nice problem. Okay, now finally we got some distributive property to do. Oh, my knees. Okay, so this one's pretty simple. This and this, so it's negative 6h. Then it's negative 2 times negative 4, so I want you to think that as a negative, right? That's going to be positive 8 minus h. Combine like terms, it's this guy with this guy. So it's negative 6h minus h is going to give you negative 7h plus 8. At some point, I'm hoping that you get fluent and understand that negative 6h and minus 6h is the same thing as negative 6h plus, right? Plus negative h. Right, so they're both negatives. I can't make 0 pairs, so we're just moving down the left of the number line. So negative 6 and negative h, or negative 1h, is negative 7h plus 8. Okay. 30y minus 10xy, because you do it in alphabetical order, right? Not yx, xy, minus, and then again, this is a minus times a positive, and negative times a negative. So next two, you're going to get negative xy. And then negative times a negative is going to give positive plus, and then y times 4. It's not y4, but it's 4y. Okay, coefficient comes first. I can combine this guy with this guy at the end. That's one is easy. It's 30y plus 4y is 34y. Two middle terms here. Right, so again, they're alike because they're both xy and they're exactly the same. So just put a 1 in there. Negative 10xy minus 1 is the same thing as saying negative 10xy plus negative 1xy. So we're adding, right? So it's going to give me negative 11xy. Again, and you should be tired of me saying this. This pen's driving me nuts. But that, you know, oh my God, pen. Oh, jeez. Okay, that's what I want for Christmas. I have my wife to buy me. So again, I'm just trying to write that negative minus 10xy minus 1. Oh my God, 1x. No, don't do this. 1xy. So again, negative 10. I'm gonna cry. I'm gonna skip. You get my point. It's not writing. Why is it not writing? Can I use my fingers? Yes, I can touch on. No. Can't use my fingers. I have to use my so again, now this one you have to worry about what do you call what to do when the bases are the same. You add the exponents, right? So 2y squared times 3y, it's 6 because 2 times 3 is 6. And the y squared, remember, if there's just a y, there's a 1 there. When the bases are the same, we keep the base and we add the exponent. 2 plus 1 is 3. Minus, because it's a positive times a negative, and 2 times 5 is 10. 10. And it's y to the second power and y to the third power. So if you keep the y, add 2 plus 3, get 5. Okay, so that's first. Minus, and then here it's negative 3y times this, and then times that. Negative times a positive is going to be a negative. 3 times 5 is 15. And we get y to the cubed. Negative times a positive is going to be a negative again. And 3 times y, 3y times y, well, there's a 1 here. Imagine there's a 1, right? So 3 times 1 is 3. And then y times y is y squared. Minus 2y to the fifth power. Are there like terms? Yes, there is. So we'll do it in order. Ascending order, and which I told you in class today backwards. So we should do the smaller exponents first. Why did I tell you that one? The small exponent is, no. Gee, I don't know what I told you in class. Well, let's do this by ascending order. So it's negative 3y squared. That has nothing to do with anyone because there's the only one with a y squared. Then we can do the cubes, right? So it's this guy and this guy. So if you think about it, it's going to be negative 15y cubed plus 6y. There's more negatives, so the answer is going to be negative 9 cubed. And this with this, they're both negative, so it's negative 10y minus 2. So let me ignore the variables, so let me just write negative 10 minus 2, right? Because I know it's going to be something y to the fifth power. So negative 10 minus 2 is negative 10 plus negative 2. Both negatives, so that gives me negative 12. So it's going to be minus 12y to the fifth power. Moving y, I can't. I think I'll use my. Hang on a second. No, I got. No, that doesn't work. Okay, next. 2c. So it's a positive times a negative, so I get negative 2c to the second power. Positive times a positive, so I did this first. Positive times a positive is going to be positive, so it's a plus. 2 times 4 is 8, and cw. Now these two, and these two. Negative 3 times, it's a negative 3 times 5, so I get negative 15. And you notice that it's BC times A, right? So they're all different. So A, I'm just going to put them in order, A, B, C. And then negative times a negative is a positive, and this is going to be called 3BCW. Remember, in front of the W, there's a 1, right? So 3 times 1 is 3, BCW. This looks like they're all different, so we can just leave it like this. Okay? There's nothing to add or subtract because they're all different terms. The other problem is I don't think they make this pen anymore that I'm using right now. Okay, so a lot more variables. Ugh, yucca, but it's not the same thing. So do the signs first. Negative and a positive is going to be a negative. 3 times 4 is 12. A, there's no A, so just A. B squared, so that's going to be B to the fourth. C squared, and just a C is going to give me C to the third power. So that's my first two. Second, negative and negative gives me a positive. 3 times 2 is 6. A times A to the third is A to the fourth. B to the second, well, that's just B to the second. C squared times C is going to give me C cubed, right? Remember, keep the base, add the exponents. Third one, negative times a negative again, so it's going to be positive. Plus, negative plus 3. A times A is A squared. This B squared times this B is going to be B cubed. And there's no C, so that attach that. And finally, the last one's also positive, plus, and it's going to be 3 times 1 is 3. A times A is A squared. B squared times B is B cubed. And C squared over here times this C here, it's going to be C cubed. Again, it looks like they're all different. Okay, remember, in order to combine like terms, they must carry the same variable with the same exponent, and they're all different exponents. right? So they might look the same, but they're not. Okay. Now we go from something that to something very simple. Negative times a negative is a positive, so that's going to be 3, right? Positive 3. B times B is B squared. A negative times a negative again. Remember, I want you to think this is a negative. It's going to be positive, so plus. 3 times 4 is 12. And B times B cubed is B4. I definitely don't want your exponent that big. Okay, so no, not that bad. I might be able to finish. I told you guys 5, but I have to eat a Parmigiana. Eggplant. Again, so this one's nice because now you can clearly tell that the 4 is being applied here that we're going to use for distributive property, not the 5a, because the 5a is just hanging out. So let it hang out. Out's here. Wait. Negative 4. Think of this as negative 4. Negative times a negative is a positive. 4 times a is 4a. And then negative times a negative, another positive. 4 times 7 is 28. And 28a. Combine like terms? Yes, they're all. So that's 9a plus 28a. And that's going to give us 37a. So here's the k case. So k, positive k, right? So positive times a negative is going to be a negative 3k to the second power. Positive times a negative again is going to be negative. K times k is just k to the second power. Copy the rest, because the rest is doing absolutely nothing. And can I combine like terms? I combine these 3 guys because they're all k's to the second power. They're like terms except this one. So it's going to be something like this, right? The minus 10k is just going to hang out. So do these 2. Oh, I'm going to put up 1 if it makes it easier for you. Okay, that's a really ugly one. Put 1 over here. So it's negative 3 minus 1 minus 4, right? So it's going to be something k to the second power. So negative 3 minus 1 is going to be negative 4. Negative 4 minus 4 is negative 8. Okay. But this is not, it's a little bit, a lot of kind of little, you got to be careful, right? Not a lot of, I wouldn't even call it a lot of work. It's just got to be careful with your numbers. Positive times a positive is 14, right? 14. W5. And then 7 times a negative 2 is going to give you negative 14. Minus 14. Oh. W5. So if you put them next to each other, if you put them next to each other, like terms, this minus this gives you 0, right? And then your final answer is negative 14. And then last one, or someone left. Right, we're going to apply the distributive property. So we're going to get 3, sorry, it's a positive times a negative. So first of all, it's a negative 3cm. And then 3m times negative, so this is going to be another negative. 3 times 3 is 9. M times m5 is m6. Keep the base, add the exponents. 3m times 6w, they're both positive, so it's going to give positive 18 mw. And then we're going to bring the minus 30w that was just out there waiting. Can I combine anything? Yeah, I can combine. I need to, well, not, this doesn't combine with anyone. This doesn't combine with anyone because there's nobody who's a CM and there's nobody who's an M6. So literally the only 2 that I'm combining is these 2. Starts over here. So 18, so again, 18, think of it as 18 minus 30, right? Which, if it's easier for you to think of it that way. And you get negative 12. Right, so I'm going to write this. Negative 9m6 minus 3cm. And then these that we just combined is going to be, don't forget the variables, negative 12mw. And we got finally this question. In terms of x, express the area of the outer rectangle, picture on the right. So the outer rectangle is this guy, this big rectangle in pink. How do we find the area of a rectangle? Well, it's base times height, right? Length times width. So it's 6b times 4b plus 2 to find the area. So I'm talking about this guy times this guy, right? How do you find the area of the white rectangle? And then express the area of the inner shaded rectangle. Picture there. So the inner rectangle is, again, same thing, like base times height, 3b times 2b minus 1, whether you, okay? All right, it's this side times this side, right? Now, let's simplify this a little bit. Let's use the distributive property. So positive times a positive is 24. B times b is b squared. Right, that's these two. And then these two, 6b times 2. So first of all, it's positive because they're both positive. 6 times 2 is 12, 12b. So the area of the white rectangle, so imagine the small rectangle is not even there, will be 24b squared plus 12b. Okay, it's expressed obviously like that because we don't have the value of b. So once I tell you what b is, then we can actually substitute and find out the actual numerical value. But right now it's expressed in this way. Smaller rectangle, the area of that yellow rectangle, well, the area is going to be, well, base times height to multiply these two, and I'm going to get 6 times 6b, sorry, 3b times 2b is 6b squared. And then 3b minus times negative 1 is going to be negative 3b. So the area of the yellow rectangle is expressed by this. Now, asking you to express in simplest form the area of the non-shaded region. So what's the area? So imagine if we had a rectangle, right, sheet of paper, and you punched in this, and you cut this away. It's almost like a donut, right? You have a big rectangular hole in the middle. So in order to find what's remaining, well, all we have to do is subtract, right? But here is the problem. The problem here is how you write it. So it's going to be area of the big rectangle minus the area of this rectangle. So when you actually write it, you actually should write it like this. Because the area of the big rectangle is this, not 24b squared, and not only 12b, but the combined sum of those. This, whatever this is, minus, and what we have to subtract, we got to subtract, we're going to punch a hole here, a rectangular hole in the middle, right? And that hole in the middle is represented by 6b squared, so it's represented by that. And that's what you have to be careful with, because if you just wrote 24b squared plus 12b minus 6b squared minus 3b, you're not really subtracting. You're not really subtracting the whole yellow part. The only part you're subtracting is this guy over here. Okay, because you want to subtract the sum of these, or the difference between these two. Okay, so when you write the expression, make sure you put it in parentheses. So the big rectangle represented by this expression minus the smaller rectangle is represented by that expression. Now, what's our duty right now? Our duty right now is to remove the parentheses. And I'm just going to sort of create some room here. Remove the parentheses, and we remove the parentheses by applying the distributive property. Well, but you might say it's going to end up the same thing. Not quite. So on the first one, if there's a 1 out here, well, it actually comes out the same, right? Because it's positive. It's a positive 1 plus 12b. But notice that here, this minus sign, if you imagine a 1 here, that's going to change the signs of those guys. It's going to give you negative 6b squared plus 3b. Right? Because negative times a positive gives me a negative, and negative times a negative in the back is going to give me a positive. Now, can I combine anything? Yeah, I can combine this guy here, this guy, and the 2 left over. So rewriting it, I get 24b squared minus 6b squared, and then plus 12b, and plus 3b. So all my like terms are next to each other. So if I combine these two, that's easy. Well, we don't even have to change it because it's positive 24 minus 6. So what's 24 minus 6? 18b squared. And then this is easy because they're both positive. 12 plus 3 is just positive 15. All right, that's it. It's not as bad as you think. Okay? And I'll go try to fix my pen.